I will go ahead and take a look at the graph, sort of a little something extra here. Graph y equals 1 over x. And I hope you know what that graph looks like. If you don't know, I'm about to remind you. You could plot a few points just to kind of position it in there if you need to. Like if I plug in x equals 1, what are you going to get for y? 1. If I plug in x equals 2, I'll get 1/2. If I plug in x equals 3, I'll get 1/3. X equals 4, 1/4. And if I look at this integral, really, this is the part we're interested in. We're going from 1 to infinity. There is a horizontal asymptote. It is the x-axis. For completeness, I'm going to put in more of this graph because I did say I would remind you what the graph looks like. What if I plug in 1/2? I'll get 2. So 1, 2, 1/2 gives me 2. 1/3 gives me the reciprocal of 1/3, which is 3. And so there is a vertical asymptote, which is the y-axis. What else do I have? If I pick negative numbers, if I pick -1, we get -1. If I pick -1/2, I get -2. If I pick -2, I'll get -1/2. We have this portion here in the third quadrant. But what I'm looking for with this integral, if I think about our last semester course, I'm looking for the area under the curve above the x-axis from 1 to infinity. To work this infinite integral, the biggest thing is write it correctly. I'm going from the integral from 1 to infinity of 1 over x dx. From last semester, I needed numbers. I needed the limit of integration to be a number and the upper limit to be a number, and infinity is not a number. So what I will do is I will write this as a limit. This will be the limit as b approaches infinity of the integral from 1 to b of 1 over x dx. The biggest mistake students will make is they do not write it as a limit. About half the class will leave that off. So, write it as a limit. I'll do the limit as b approaches infinity. What's the antiderivative of 1 over x dx? ln, natural log, absolute value of x. That's going to go from 1 to b. Then plug in the b and the 1. I'll do the limit as b approaches infinity of the natural log of the absolute value of b minus the natural log of the absolute value of 1. I really don't need those absolute value signs right here because 1 is a positive number, and b, since b is going to infinity, it's a positive number. But if you're not sure, put the absolute value signs. What is the natural log of 1? 0. So this becomes the limit as b approaches infinity of the natural log of the absolute value of b What is that limit? Well, for this, you might need to remember what the graph of the natural log of x looks like. For this one, I'll put this on the side. Recall y equals the natural log of x. This graph passes through 1, 0, because the natural log of 1 is 0, and it has a vertical asymptote, and it's this. Now, if you graph this in your graphing calculator, if you have one, it's going to look like the graph sort of levels off and becomes horizontal, but it does not do that. This graph keeps increasing, even though it looks like it's increasing very slowly. It is increasing forever. What is this limit? That's infinity. So this infinite integral does go to infinity. This area under this curve from 1 to infinity is an infinite area. Now we have a word for this. If this is going to infinity, we would say this diverges. Or if it never settles down to a certain number, we'd say diverges.